In this video, I'm unboxing and setting up the EcubMaker DIY 4-in-1 3D printer, and we're starting right now. Hello, my name is Daniel. Welcome to the Crosslink channel. I would like to help you being more successful with 3D printing, and if you're here for the first time, subscribe and hit the bell notification so you don't miss anything. So, today's the day. I'm unboxing the EcubMaker DIY 4-in-1 3D printer, and this is sponsored by EcubMaker. They've sent me this device for free. Thanks very much for that. So today we're gonna have a first look and get it working and getting some 3D prints. And in the follow-up video, I'm going to have an in-depth look at all the individual functions, because this is an interchangeable tool head device. And I also have a super exciting announcement to make. After I've done these videos and after the review is done, I'm gonna give it away to one of you. That means you're gonna get this printer for free. And to register for the giveaway, please go to crosslink.io/free and register already. So we're gonna do this in about 1 month, and then we're gonna send this printer out to the winner. And also, if you want to buy this printer, I've put a link in the description of this video. So you see, this is going to be super exciting. So before we start, just want to have a brief look at the spec sheet of this device, so you have a first impression of what this is all about. This is an all-in-one machine. It supports 3D printing, dual color printing, laser engraving and CNC engraving. And it is also a magnetic platform with automatic bed leveling, a slicing software, so we're gonna have a look at that as well. And it has a 180 by 180 by 180 millimeter printing volume. So you see, there's lots of things to discover, and let's just open up the box right now. So this looks like the main unit. I think the most complex thing is gonna be to get this thing back in a box when I send it to someone. So let's see how that works out. But let's get it done first. Let's get it mounted first. So this is the main unit, and we have another box here which is labeled mounting. So let's have a look inside. Yeah, we have a manual. This looks like a very short manual actually for the assembly. So what do we have here? We have a filament holder. So what is the toolkit? That is cables, and USB stick, memory card, replacement fittings, screwdriver, power cable, USB cable. Oh, we have an external power supply. Let's put that here. We have some protective sunglasses for the laser engraving, sample acrylic parts, and some sample wood parts and print surfaces, and a CNC carving raft, which seems to be used for mounting the CNC part that you want to engrave and then carving on top of that. And this is another surface that looks a little bit heavier. That's probably the magnetic surface. A drill head for the CNC and carving, dual printing head, the CNC tool head, a laser tool head, some PLA filament. Actually, I'm gonna save that for the giveaway, so I'm not gonna touch that. So let's have a look at the tool heads. Let's start with the 3D printing tool head. This is the 3D printing tool head. You can see these are the sliding slots, and then it's going to be mounted, and it has dual inlets for the filament, so you can use it for single PLA or dual PLA printing. And then we have a connector here to be able to exchange that quickly and easily. Next is the CNC tool head. See it here. This is the motor that's turning, and where we can mount the drill head. And finally, the laser head. So see here, this is the laser outlet where the laser beam is coming out. Has the same mounting mechanism, so it's pretty modular, seems. So we're gonna start with this 3D printing tool head and mount it to the printer and getting it set up for its first run. Let's have a look what we need to do. The manual is actually pretty short. Unboxing. Blah blah blah. Remove it from the box. It's not, the flat cable is not a handle. Yeah, obviously not. So you can see the PTFE tubes are coming out of this this cable chain. So it's all in place already. So the only thing that you need to do is plug in the cable. Just plugging in the cable for the CNC engraving and laser engraving, and for the 3D printing, just adding these 2 PTFE tubes, and I think they're not going to be in the way when you don't need them. The idea is that you just have to slide this over this mounting plate. In this zip bag there is a mounting screw that looks like the right one, so we have to put it in here. This is holding the head in place. The other thing that I see here, we have this 3D printing surface, and it looks like this is a magnetic tool surface. Yeah, so we just have to put this on. Okay, we have colors. So there is actually 2 different colors here. The blue one to the right side of the tool head, the marking red into the left side. So I'm guessing this is gonna be left. Then we are plugging in the cable here. So according to the manual, this should be everything that we need to do in terms of the hardware installation. So plugging in these 2 PTFE tubes, plugging in the cable, making sure that the tool head is mounted and fixed with this hand screw, adding the printing plate on top, and now we're gonna insert some filament into the extruder. So I just need to find out which one it is, and plugging in the power, and then let's try if it prints something. Let's see. Okay, so I've got some gold filament here that we're gonna use. I'm pushing the filament in until it's gonna be at one of these colored markings here. Still have some doubts about this whole setup here, because if it's gonna pull here, it's likely going to break, and this is not moving quite easily. So what I'm going to do now, I have these very simple filament spool holders that it's just 2 ball bearings in between 2 PLA parts, and it's normally it turns super easily. So even if there's some force here, we're just gonna turn around the spool so it can pull from the bottom. And so this is probably not gonna cause any kind of issue. So this one, I really don't recommend to use this. So unless you modify that and add some ball bearings here or some kind of PLA part that makes it turn much easier. One thing that I notice here, which gives me a little bit of a headache, you can clearly see that this is off by just a few degrees. I don't know how this is exactly fixed to the bottom part, but if it can be fixed by just loosening these screws and then tightening them again, this could be good. Okay, and this looks like it can be fixed. So this looks good. So power goes into the back side. Then we have the main power switch here at the front. And does it work? Okay, seems to boot. How's the noise level? Getting a little bit louder. I'm just switching to another microphone because it's gonna pick up less noise from the printer, hopefully. So the printer by default is in the Fdn mode. That means it's ready for 3D printing. To see that, you can always go to this printer menu here and go to utility, and then say go to the change tool header, and then it's telling you in the last menu item here, it's currently in the FDM header mode. That means we are in the right mode. I'm going to see whether the auto home of this printer is currently working and if we have to do some bed leveling adjustments, or is this also working completely automatically. There's also a function that's called Z offset, so I guess that this has to do with the actual final distance of the nozzle to the print bed. I don't actually know if that's correct right now. It's written on the manual that it has been set up in the factory. I don't know if that's still correct. Because I also fixed the position of the printing bed. So let's just see if the auto home works and the auto leveling works. So we have to go to the utility menu and then say auto home. I'm just curious what's gonna happen right now. Alright guys, so one thing that I noticed immediately when I tried to do the auto home was that the Z-axis is actually not moving, and that means somewhere there is friction in this whole Z-axis system. So I took off this top cap here, which is covering the Z-axis lead screw, and what you can do here with a screwdriver, you can try to turn the lead screw, and currently it seems to have quite some friction. And then I found also by just looking at the x-axis, by looking at this horizontal bar here, I recognize that it's actually not quite level versus the print bed and versus the table. So I loosened these two screws here, which are holding the whole x-axis bar, and then I can now take it and just turn it a little bit, and you can see that the lead screw here is also moving with it. And you can imagine if that thread of this holding part here is just a little bit skewed against the lead screw, it causes friction. So if you bring this whole bar back into a horizontal position, and best would be to do this when it's on the lower position, so you can see also the distance to the print bed, then you will see that now, since it's now quite level, it moves really easily, just almost by its own. I just give it a little bit of a kick, and then it's already coming down, so I can probably push it down now. So now it's really moving very easily. So I think I found a position where this x-axis bar is horizontal, and also the nozzle distance to the print bed is almost perfectly equal on the left and on the right hand side. And then I tighten these two holding screws back into position. Let's do a final test if the z-axis now is still moving easily, if it still doesn't have any kind of huge friction. And yeah, I think it's still good. So since I now fixed the horizontal x-axis bar, so it's absolutely parallel with the print surface, we can give it another try and run an auto home. And I'm gonna explain to you how the auto homing in general works on this printer, because I think it's pretty unique. So the first thing you notice is that it's not going down, but it's actually going up. And we have this little pin here that's sticking out from the top of the extruder. And this is going to hit this upper plate here where the lamp is. It's gonna touch it, and that's going to tell the printer, okay, this is the upper end. So this is the upper limit, and I'm going down from there. And what's going to happen at the same time, it's gonna push out this little Beal touch pin here that I'm gonna show you in a second here. This is the pin that's coming out. As soon as this gets pushed in, this pin that comes out, and this pin is then going to hit the print surface and do the actual auto leveling. Okay, so that's it about the auto home. Another thing that we should do before we do the actual first print is to set the Z offset, because I'm pretty sure, although this has been set up in the factory, and because we had to recalibrate the x-axis position, probably everything is off by now. So let's run through the Z offset settings. This is also a menu item here, which is called set offset, and then you have something that's called auto set Z offset, and if you hit that, you have a 3-step menu, which has step 1, which is going to do an auto home, and then we have step 2, where we're adjusting the offset, and then we have step 3, which is saving the settings. And so what we're gonna do first is an auto home, and then going to the next step. And it looks a little bit strange, so it looks like it's going to do the same thing again, but what's actually going to happen right now is doing another upper limit check, and then it's going down and doing an actual mesh bed leveling. You can see it's going through multiple probing points, and it's going through kind of a mesh of 9 points, I guess, just to see how the surface looks like. Okay, so first step is done, and we're heading over to the next step, which is adjusting the offset. And as usual, I'm taking a piece of paper here and putting it in between the nozzle and the print bed, and then I'm setting the set offset, and I can now bring it down. I should feel the paper having resistance between the nozzle and the print bed. So let's bring it down. Yeah, and that looks pretty nice. And I really recommend to have a good amount of resistance, a good amount of friction. This is going to help you bring down the first layer and squeeze it a little bit into the print bed so it really sticks better. If you can hear it and you can feel it, that it has a good amount of resistance and it leaves some scratches on the paper, I think that's the right distance to go with. So next step, after we've done that, is to go to the save and reset menu item. Don't forget that, otherwise it's gonna not save your settings. Hit this, and I think we're now ready to actually do some test prints. So I'm going to start a test print from the SD card that was delivered with the printer. So let's do an FDM 3D printing test. There's also an FDM dual 3D printing, which I'm not going to do right now. We're just gonna do one color. So the first thing that I see here is that I think the brim, or what it's called, it lifted up just a little bit from the print bed. So I could have done better with the leveling first in the first place. But overall, it's just stuck to the print surface. It didn't really release from it. The other thing that I see here is a little bit of a problem here on the side. I'm not sure what this is. This is kind of an artifact. But overall, I think the print quality looks pretty good for a first print. And yeah, it releases quite easily from the build surface. So that's also nice. What we're going to do right now is I'm going to insert a second filament, and we're going to do a dual color print, which is also on the SD card, just to see how that works, if that works seamlessly, and how the quality of that dual color print looks like. Let's insert that black filament here. If you insert the filament, you should stop right here. What the printer is going to do on its own is going to insert it the last few centimeters every time it needs to change the filament color. So I think I can see another issue here. If you look closely at the belt, you can clearly see that the belt tension is really poor and it's wobbling around, it's really sloppy. So I think that this can cause all kinds of issues. Especially we look back at the print from before, which had these, especially on the x-axis, these issues. This could be caused by a not really well tightened belt. Okay, so what's now happening, it seems to be unloading the gold filament, and now it's feeding in the black filament. I'm just curious how that's gonna work. Does it need a purge block? It doesn't seem to be, at least at the moment, it doesn't seem to be using a purge block. Oh yes, I can see what's happening right now. So this is pretty clever actually, but it's pushing out the filament here on the side. It's just purging the filament here onto this little slide on the side, and then it's running over these rubber pins here and just scraping off the rest of the filament. So that's actually a pretty clever way to get rid of the old filament color, and just sitting here and extruding and then going back to the print. So the dual color print finished quite well, I would say. Let's take it off the plate. So you can see it's also pretty easy to take that magnetic build surface off, and then you just sweep it a little bit to the side. You bend it and it's just easy to take things off. So I think you've seen hasn't been a great issue, but on the other hand, I still see some distortions here. So I'm not sure where this is actually coming from, if this is a slicer issue or if this is actually something in the printer. But I already pointed out that this belt here is pretty loose, so this could be an issue. Another thing that comes to my attention is this cable here. So let's have a closer look here. This cable that comes from the heat bed, or that's basically connected to the heat bed, and that's probably both the power supply for the heat bed and also the sensor. If that is somehow, and that was happening all the time, if that gets squeezed in here at the end of the rail system, it can potentially get some damage over time. So I think it's not the best design choice to let this run just over this case. I would at least have added some protective sleeve or a tubing. Then, I mean, the alignment of the x-axis bar, probably I made a mistake when I took it out of the box. It could be that I mistakenly somehow skewed it, but it's easy to fix. Also the heat bed, I just had to release some screws to really get it aligned. That wasn't a big issue. And last but not least, there's two other design decisions that I really like on this printer. First of all, having a full-size SD card slot versus this micro SD card slots that all other printers that I know have. The second thing that I really also like is the full-size USB port here, so you don't have to use micro or mini USB cables. The whole design I really like. It's pretty industrial. Everything is covered, so there's no, like for example the lead screw here, it's inside this metal housing. On the other hand, this display here, if you have a look here, to be honest, that isn't the greatest design decision, or that isn't the greatest decision to use this kind of display. It's just a very small display. It's just dual color, not a very great choice. Then you can hear it already. The noise of the printer is pretty crazy, I would say. It's super loud, even if it's just doing nothing. So the housing or the electronics case fan here seems to be the issue. So I can imagine just changing that out with a better fan could reduce the noise significantly. Actually, extruder fan isn't that kind of a big problem. That wasn't really so present. Another detail that I really like is this lamp here. Really a nice design choice, just to have something lighting up the printer if it's running in a dark room. And of course the rail system is also a nice design choice to have rails on all axes. This will probably help to improve the print quality a lot. I think the design choice here to have this slide mechanism where the filament is just sliding down when it's got when you change the filament color. So here on the side you can just the printer can just squeeze out the filament very quickly, and so it can change filament color probably faster than a printer that has to use a purge block and that doesn't have this. This is also pretty clever here. I hope you can see it. You have these rubber stand-ups, and every time the printer nozzle goes over them, it scratches off any kind of filament that's extruded from the nozzle, that's still hanging out from the nozzle. So overall, I would say there is a few really nice design decisions that I really like, and there is a few little flaws that can be fixed easily, so nothing really severe. The only thing really left is the print quality on the x-axis. I guess it's the x-axis. I think it's this belt here. So this should be tightened, and then we should repeat this print. And I also like to remind you again that I'm giving away this printer by the end of this test series. So register here at crosslink.io/free, and I'm going to send it out probably in about 4 weeks when this whole series is done. And why I'm doing this is mostly because I think someone from the community really deserves to get this printer. I have a lot of printers, and I think this one is really very exciting, and I can imagine that this will make someone from the community of this channel very, very happy. So if you want to be that one, just don't forget to register. And also don't forget, there is links in the description if you want to go and buy this device. So thanks, and let's head on with the test. So I think the way how this is supposed to work is just loosening this grub screw here. Yeah, this is responsible for holding the belt, so I have to give it a little more tension, pull it up. It looks like it's a little bit more tightened, so hopefully that's going to improve our print quality just a bit. So let's have a look at the print result with the belt tensioned. So I'm going to take it off the print bed. So let's have a look at the result here. I mean, you can see already that just by tensioning the belt, it's so much better. It's really astonishing. So this was the previous one, just to give you the comparison. And this is a huge difference. Belt tensioning on this printer makes a huge difference and brings a lot better quality. So yeah, I'm pretty happy with that. So this was part 1 covering the FDM printing. It was a long video. I hope you're happy still watching this. In the next part, I'm going to cover the CNC machining and the laser engraving, and also a bit about the software that's coming with the printer, as well as the firmware upgrade that you might want to have. Stick around, watch the next video. I hope you like it, share it, subscribe, all the good things. See you next time.